Cool. Okay, so I have a YouTube stream back again. Okay. Stream reconstituted. So now the question becomes, how do I detect that a lock condition will occur? Man, I really don't want to have implicit error checking requirements on everything. I don't like runtime errors. They're bad. Do it like Rust? This is me trying to do it like Rust. If I wanted to do it like any other language, then it would not be a problem. I would not be stuck on this. But the problem is I am Rust-brained, and I want to solve the issue in the compiler / build step rather than at runtime. There's no way I've been streaming for 4 hours just yapping about this. I'm looking at my stream manager, like Twitch stream manager. That whole mutex lock gotta have frame fast issue. It's not a mutex. The problem isn't mutex locks. I can prevent mutex locks, but that will result in runtime errors. So the problem I'm trying to solve is how to predict mutex locks, and warn the user about them. Oof. Yeah, I feel like I've been streaming for 2 hours at most. Never quite fully understood the explanation of what those unsolvable issues were. To me, computers always felt they could do anything eventually. Well, this is the result of unmedicated ADHD. ADHD isn't a lack of focus, it's a lack of control of focus. And the problem is I'm too focused on this. Never quite fully understood that. Yeah, the problem is this is potentially an impossible problem to solve. And what I need to do is what I need to do is... What I need to do is be satisfied with a good enough answer, basically. No, I said I'm unmedicated. I probably did watch that video, but I'm not quite sure exactly what you're referencing. Currently, we are trying to solve data race conditions, basically. Not necessarily mutex locks, but making sure people are aware what version of data that they're awaiting on, and if it's even possible to await on the data that they're attempting to await on. Yeah. That is about the gist of it. Because another one of the solutions I thought about was, what if entities could register callbacks, and other entities, instead of requesting data, could just listen to the data from those callbacks. And then, of course, you know, if that data has already been provided this frame, then it's just given to the requester. if that data has not yet been provided, you just await until the data is provided, which is kind of what I'm talking about here. When this entity is awaiting for data from this entity, what it's waiting on is one of these callbacks. Because that is very explicitly, I want the data as it exists in that point of time. However, this data does not exist until this point in time. There's a hard cutoff here of like a lock that it will, before this hard cutoff, maybe the solution is like before this hard cutoff, this data shouldn't even be available to await on. That's one of like the static solutions to this. And that's like, now let's break up our update loop into several segments instead of one tick function that encompasses all updates. And I do kind of plan on doing that for like, because tick is basically like a request. The every single object that like needs to tick provides the tick interface, and then the scene themselves provides, or not provides, requests a tick from all objects. So I guess this awaitable data paradigm isn't very viable. Just at all. We need to either use the very standard game engine approach of implicit data paths. And by implicit data paths, I mean something like, here's the position of an object. Let's say you have a physics system, an animator, and a physics system and an animator is good enough. So throughout the lifetime, let's say you have a position of an object, and the position of the object, you have the last frame position of the object, and this is the last like value of the object. And then at any point, another script could read this data, and they would get the last frame. And then let's say we have the physics system, and let's say, for the sake of argument, the physics system is on a parent entity to this object, so it's not directly driving the position of this entity, but it is affecting it. And then, so this is the physics influence on this object. And then at any point, entities could grab the data from this object, and that's the data that they would get from this object. Then we could also have an animator. And you kind of get the idea. The data they get here is the position after the animator has affected it. And then you finally get the current frame position or next frame's last frame position. And this is kind of like the result. So we don't really need to worry about This one and this one are basically the same value, but actually, say it's like the render, and now within here, in our standard, I don't think it's the best way to do it. I have run into many bugs because of this, and that's why I'm trying to solve this. Because the problem of timing and not knowing what is affecting your data is like, this is kind of an effect of like me going so deep into functional programming, but I don't like stuff affecting my data and not knowing that it's affected my data. Now, let's say I always want to use the last position of this object rather than this frame's position of the object. Those are two different values, but they have the same name throughout the entirety of the frame, and my scripts need a way to be very sure that they know which version of this they're referencing. In Unity, you have no way to know which version of it you are referencing, but you have to be aware that there is physics, and you have to be aware that there is an animator on that object, and then time your, when you grab the data, to be grabbed right here. Or you need to time your data to be grabbed here. Because realistically, these are the only two versions of the position you want. This could be entirely different for different values, but generally you want a before transformations and after transformations version of a value every frame. And I've run into a lot of problems with this, especially with like working with IK systems. An IK system very much cares about, do they happen before or after an animation system? For the animator, you generally want to do IK after an animation system. And in this particular case, we don't really need to worry about animators versus, we don't really need to worry about animators versus IK systems, because the way that we're doing this, animators are... The timing of things is explicitly described in the tick loop. In this loop, you explicitly call animator, and then you explicitly call IK, and I don't think we're going to do a mesh renderer, skinned mesh renderer, the same way that Unity does it, where the bones are physical entities in the scene. I think that it's going to be implicit, similar to the way that Unreal does it. And then if you explicitly want a bone position, you're going to have to grab that and calculate it, at least at first. Considering dim Sony stuff, IK might not even be used by the time this is fully released. But you get like the idea of like, okay, now it's like the physics system needs to run after the animator instead of having the IK run after the animator. Now you need physics running after the animator, because you need your physics to match up to the position driven by the animation. So you run into timing, like, when am I grabbing this data issues all the time. In fact, like, I believe the way you say his name is, I know his last name is Tyroller, the guy who made Will You Snail, and then he has like a newer game since then, but he talked about how in their game, they literally removed... They're not using any of the standard Unity update stuff. They made their own script that calls other scripts in the scene for solving exactly this issue of you don't know when Unity's doing anything. And you need to like make sure that your scripts work exactly when you need to do stuff. Where's the IRL magic system? I don't even need an IRL magic system. I'm trying to invent the magic system. Thank you, water bottle, for functioning properly and spilling water all over me. And basically, I have solved this issue within a single entity. I have solved this issue. We know when things are getting updated within a singular entity. Because of this update tick system that is fully handled. But what we don't have handled is we don't know how to make two-threaded systems. I have this opaque system in one entity, and I have this opaque system in another entity. How do those systems communicate with each other? Well, the magic system is blowing up on me right now. We're trying to make magic systems that don't blow up. Or I'm trying to construct a spell that doesn't have any possibility of blowing up. And the solution in some form is message passing. But the problem is, if you're doing message passing, you at some point have to respond to messages. So we run into the issue of it taking multiple frames for entities to communicate, and I don't want it to take multiple frames for entities to communicate. All of this gets solved. All of this gets solved if we make it so it takes multiple frames for entities to communicate. And I just go with a message passing approach and essentially do an actor model. That solves all of these issues. I don't want to do an actor model, though. Bevy referenced. Yes. Because Bevy can solve this problem. Because you have all of your scripts in one place. And you know everything that's going to happen. I don't know everything that's going to happen. I can't control the code being written by other people and then getting loaded into my scene. And, okay. To further explain, like, how I was trying to fix this thing, is these callback data events is like, this is a callback to get the last data, this is a callback to get the current physics data, this is a callback manually defined to get the animator data, and finally there's a callback to get the data after the animator. The problem is when another script defines, hey, I need the after animator data for that other entity and the other entity. Yeah. The whole circular lock problem again. It is. We are getting into the fun stuff right now. This is the main issue I have not solved. It's like, what does the scene graph look like? How does our update look like? Update loop look like? Yeah, see, you know what I'm talking about. ABBA. I'm trying to figure out a way to, like, detect this before it happens and then make coders not able to do it. Not able to cause it. And I can't think of any way to do it but making communication between entities take multiple frames, multiple iterations. Or, the other way you could solve it is explicitly do message passing, but then explicitly respond to messages multiple times throughout a frame, but then you're responding to those messages with potentially different data multiple times a frame. And the other solution to this is when this wants this data, you could give it the data from last frame. And then you have the same issue of now it takes multiple frames for like changes to propagate through entities. On the same file. I could. That's kind of what I do with the Notion documents. But I would need a different program than MS Paint to show that off. Thoughts on how to fix a similar issue in a custom ECS is that if a try lock fails for some write access, get an upgradable read lock, and then record mutations for the entity and then update the entity with the mutations later. So I don't necessarily have the issue of write access because in this system I explicitly don't want every single system in the engine is going to be locked to one particular archetype, basically. Tagged archetype. You explicitly say, I want this object to be of this type. Because generic ECS, if it's like a user-generated system, like, if I load systems from one user and load systems from another user, their systems might cause conflicting effects on their entities. So entity component systems only really work when you're working in a system that you fully control yourself. But if you have other potentially malicious authors in there, or not even malicious, but just unknown authors in the same system that can't test against your code, you run into the issue of you just need to sandbox it. You can't get around not encapsulating stuff. So the other way I'm encapsulating this is I only want mutations on other entities to occur through methods defined on, or methods exposed by a certain archetype, basically, like interfaces. Way to do that would probably be to draw on walls in VR with brush tools. Problem is, I don't have enough fine-grained motor control in VR to actually doodle effectively. I have legitimately tried, but it takes me way too long to write stuff. But I have times where I've gone in with the other engine developers and we were both describing our different architectures, and it did look like that. We filled an entire instance with just doodles of different engine architectures. It was pretty fun. You just make a version of Brane Engine where you shrink it. It's a hardware problem, not a software problem. ECS is very good for performance, not for gameplay systems necessarily. It's an interesting way to think about problems, but I do think like the standard update loop-esque ideas. Just draw big and then shrink it. No need for fine motor control. I see. No need for fine motor control. The thing is, yeah, drawing big doesn't work because I can't draw big fast. I can draw small fast because it's all wrist. Like, you know, well, not even wrist. I'm moving my fingers around to write. And I can't move my fingers around to write with a controller. See, wrist stationary. Pen. Do that. That's how I write. And it's kind of hard to do that with unless like I'm holding a controller like this. It doesn't. Still, I guess I could do like this. Kind of. I think that's how like pencil does it. And you can write it like that, but you do need to like be able to rest your hand against a surface. It's the fine motor control that makes it viable. So we can't get rid of the fine motor control. Also, I don't need to do the appearance. I don't need to try for the appearance of crazy, because I already am crazy. You guys know this. Okay, and the thing that I'm entirely ignoring with this current system that I'm trying to figure out here is that I really like reactive systems. So this is one potential paradigm I was considering. This is one potential system that I was considering was entirely reactive systems. Now, this is not a reactive system here. This is an event-driven, event-driven update loop. So when you want to update stuff every frame, just do all the potential like updates. This is Unity-esque. There's an entirely different architecture that I could go with that is still potentially susceptible to the mutex locks. But that architecture is... there is no structure. There's only mutex locks on specific component data, but then we don't even have like a specified update loop. It's just kind of all in the air, so to speak. Maybe then... you know what? So there's two paradigms that I could go with. And I'm gonna make sure that I fully express the second idea before stopping myself from talking, and before talking about a different idea I had while speaking. And that is here where we describe everything that an entity could possibly do and put it in the tick loop. There are no other events. This is everything the entity possibly does, and that is essentially the actor model. You have an infinite loop, and your actor controls its own state entirely, and controls its own control flow entirely, and yeah, it can never be in... If you write it well enough, it's uncrashable and unlockable, basically. But the other thing is we have an entity type, and it has components. These are the components of the entity, and then we have a list of interfaces. So I have these requests you can make to the entity, and then here's code that goes off asynchronously. All of these are asynchronous. It is enforced that all interfaces are potentially asynchronous. They can return immediately, and that will be like mostly single-threaded. But you have these things that go back and do stuff, and then on these events, they can request component data, and then lock that data, and then return data back. But then we're back to the old game engine system of, like, when you request the position, you get the position of the entity. When you request the animator, you get the animator, or when you request after the animation event occurs, you get the pre or post animator data. And also my idea is that entities would be able to, if a component stores a reference to an entity, they could request that actions occur on the other entities with these interfaces. And this is like, this event space model is a relatively recent idea I had. This interfaces model is a little bit of an older idea. The problem is this event space model still has a tick interface, because some people want to do stuff every frame, especially if you want stuff to be deterministic, which I do. I want my system to be deterministic, and if you let stuff happen in different orders, especially because of multi-threading, things become non-deterministic. Now, this system works fine on Unity, because Unity's update loop is single-threaded. So it can have race conditions, but they are deterministic race conditions that also happen every single time. Do you know of any good resources for multi-threaded async game engine design, or are you just spitballing? Asynchronous game engines don't exist. They have not been invented yet. All major game engines have been invented with the idea of, here's our main loop, and everything executes from the main loop. Unity has a job system, Unreal Engine has a job system, but none of them have gone from the idea of, let's make everything asynchronous. At the end of the day, there's still the idea of, here's a main loop. Now, I think Bevy might be fully asynchronous, but they have the benefit of, they're not a user-generated content system. So you can explicitly map data dependencies, whereas I can't explicitly map data dependencies, unfortunately. Yeah. And the problem is, it's a really hard problem. Like, and there's not... If I had found a correct answer, I would have gone with it. There's only, like, how good can you get? Who can come up with the least wrong solution? And I feel like I'm drifting towards, I really like the idea of an interface-based system. I really like the idea of interfaces. Interfaces for grabbing data. Full of unsafe code and requires expert handling. Unsafe code is only unsafe if you don't understand it. But the expert handling is the important part there. If I was designing my own, an engine for internal use only, which this is probably going to be used for the game studio I work at eventually. Like, we've had conversations, we want to use Brane Engine internally at some point. So this is essentially, not like fully officially, but Brane Engine is the internal engine of studio name here. We haven't fully landed on one, but there are a few contender names for this actual studio name. The most the least buggy solution to all of this is interfaces only give you read-only data, and they only give you it for a specific previous time step. So you can only ever request data from entities about previous frames, not about the current frame, unfortunately. So that's kind of an impulse-based system, almost, where everything that happens on one frame is only able to affect the next frame. Yes, the Thrill Seeker one. Yeah, I'm of the same opinion. The whole, like, the solution to all of this is don't do it. Use a main loop. That does seem like a cop-out to me. I do think there is a solution here, which is why I have been stuck on it for a month, is because I do think there is a solution. But the problem is, most of the solutions are design everything carefully, but you do have the potential for errors, and then just test it thoroughly. User-generated content. User-generated content. I think the actor model do I have to go full actor model on this? I might have to go full actor model on this. Demos with user-generated AI model content. Talking about Horizons? Or... yeah, I'm not quite sure what you're talking about. One experience for internal use. Async await with explicit structured concurrency and message passing are the only required. Where required seems the safest and least overhead threading model. Yeah, like what Bevy is doing is the most performant thing you can do. I can't use Bevy, unfortunately, because I need to be able to encapsulate stuff. Trying to think, how would I do something similar to the full actor model, but performance was pre-computing the update diegetic syntax graph, or DHE. I don't know what that stands for, but I have I know what it is, but I don't know what the acronym stands for. Just events. Events are harder to implement, and you're just never running a ton of logic. I'd like to see something like Bevy, but with more dynamic parallelism, but even at the cost of slightly more overhead. Yeah, I am definitely going to have more overhead than Bevy, unfortunately. So the thing is, I designed this whole pipeline system to basically support multi-threaded talking between multiple threads like this. But I'm not sure I want to use pipelines for the update loop at all. Dang it. 5-hour stream and I still have no... I don't feel any closer to a solution. This particular stream. So this is... I think we were at 4 hours before my internet cut out. And then it's been an hour since then. Does OBS have a... Well, actually, no, I've stopped OBS. That's 2 hours and 30 minutes, and I haven't ever clicked the stop streaming button. So might be closer to 2 hours and 30 minutes total. There isn't one? Currently, there isn't one. Yeah. Currently, the solution is not to have blocking events like this, and just trust people to ask for data and be smart about asking for data. Someday there will be computer science white paper on the problem. I'm probably going to be the one that writes it. I'm probably going to be the one that writes it. The solution honestly might be just to like start coding and then be like, just like fuck it, we ball. And then if I figure out a solution, then refactor the system to support that at some point. I really like this update loop of there only being one tick function, and I really like the interfaces system like this. Order of data. I still have not solved order of data between different entities, but this situation I'm trying to solve here might actually be unlikely if I architect the system well. Because a lot of this has to do with visual stuff. So this is the tick function. The tick function will not influence anything visual. Now, IK will happen there because that some compute stuff, like if you're doing hitboxes and stuff, you need to run IK on the server. But stuff like sending, or basically just the visual entities that you see, a lot of this messy behavior happens because of like visuals and different systems requesting stuff, and visuals are going to be a different request than the tick update. Like explicitly, there's going to be a different update stage for visual entities because they will only exist on clients and they will be purely visual. That is one architecture thing that I've decided on. Is, let's say you have a player entity and then you have the visual representation of their avatar. The visual representation of the avatar is going to be a different entity than anything like that is like state of their avatar. Like visuals is going to be different, I think. That, or we're gonna have conditional, like, here's how it updates on the server and here's how it updates on a client, which I do want explicit. Here's how it acts on the client, here's how it acts on the server, as different pieces of code. Which is what the purpose of the visual was. Because servers don't need to store visual information about certain entities. Now I'm second guessing that architecture choice too. Anyways. Transactional memory doesn't even help because the problem is I'm trying to solve is wants data that doesn't exist, and the data can't exist until operations that happen after we have the data. I require this data to generate this data, and I require this data to generate this data. That's absolutely good, Mr. Wiz. I am doing well. The code is not doing well. The logic problems are being not kind to me. Yeah. Okay. The solution is to just start working and know that I'm still gonna have this. Both of these bugs. We're still gonna have locks that can crash objects. If they try it, it's not gonna crash the frame, but it's gonna crash objects. First thing that comes to mind is a thread that's a dedicated arbiter. That's called a main thread. That's explicitly what I'm trying to design out of this system. If you have consistent events that happen throughout the frame, like say a main thread, and like I will have to have a main thread, but that arbiter you're talking about is a main thread basically. If you have a pipeline of physics into animation, etc. Could you have hooks on the entities with an async function that would return the new data for animation? That is basically what these timing-based events were attempting to be. Like, this event fires when this data is available. Like, there's a promise you can wait for when this data is available this frame. You still have the deadlock condition. You have the deadlock condition on every way of passing data. Just some systems don't have deadlocks because they implicitly pass you stale data instead of data generated this frame. If you don't have a deadlock, it's because it's using stale data. So basically, I'm going to have to be fine with people dealing with stale data. The problem is because of threading, stuff doesn't happen in a deterministic order. So you have to get people to choose whether they want data from this frame or stale data. And then I'm going back into the thing. I can always give them stale data. I can't always give them current frame data. And the solution to the stale data problem is to have an insanely high tick rate, so fast that there's like 5 ticks in between each frame. That would solve the stale data problem. And you can code most entities to not require an update loop. If you have callbacks for every single event imaginable, you don't need a tick loop anymore. However, if you want deterministic systems, you need to add time in somehow, and as soon as you add time in, it breaks. Will that equate to saying get a better PC? That'd fix it? And not necessarily, because if I always run multiple ticks before rendering a frame, you don't notice that there was frames of lag or lag between updates. And what I'm most worried about is you press a button and 2 frames go by before the result of that button getting pressed occurs. Or multiple frames. Like, if you press a button and it causes a chain reaction of different systems to communicate with each other, that has to take time for the messages to propagate out, and then back in to whatever visual thing you see. Which is actually how stuff happens in real life. Like, the tip of the pen doesn't move immediately when the base of the pen moves. There's a shockwave of the atoms moving, and they're out of sync with each other. But because the tick rate of reality is literally infinite, you can't perceive the speed of sound, or the speed of messages between atoms. Like, stale data is how the universe works. You're seeing this several milliseconds after I'm saying anything. It's taking time for light to get to the camera. So basically, if I want to be like super pseudoscience about it. I'm trying to optimize out the speed of light from my software. Quantum entanglement, though, you can't send data through quantum entanglement. I would be able to model quantum entanglement just fine in this system. The problem is, I want to model passing data, and you can't pass data faster than the speed of light. But I'm trying to simulate. If you model your logic perfectly, you can do it in a single step of time. Solving the problem I want to solve. I get to choose. Sometimes data is stale and it causes inconsistencies. I can get fast non-determinism, or I can get slow determinism. With the ways I know how to solve this problem right now, those are the two options I have. Yeah. How can you even make it non-deterministic? So, the speed of threads on a computer is effectively random. There was a time in the past when you could, look at the generated assembly and you look at the documentation of a CPU and you would know exactly how many clock cycles it would take to execute a block of code. Nowadays, your CPU literally does a ton of stuff like branch prediction, and various other extreme optimizations that makes the speed of a CPU core unpredictable. Physically cannot predict it. Now, because this is a multi-threaded system, you have multiple things acting in parallel. So, and there's a little bit of randomness to how much time each one of these things might take. So, if the result of these computations relies on the result of things happening over here, and I say, this value here, I want this value, but I don't specify do I want the updated version of it or the past frame version of it, I'll request and I'll get that data back. And in the situation where I enforce you can only query data from other entities from a past frame, or you can only get messages from those entities for a past frame, that means that deterministically I know that even though it's taking different amount of times for all these different things to occur, it's only using data that I know that data will always be consistent. Whereas if I say give me the latest version of this data, this frame, then there may have been computations that happened that changed that data. And then instead of getting the previous frame data, I get that frame data, which would be slightly different. And then over time, let's say I have code running on a server and code running on a client. Their frame timings are going to be slightly different. The previous frame versus current frame data that they'll use are different. So over time, you get entropy where the calculated result, like state of the world on the server, diverges from the state of the client. It's just a double buffer, they're objects all the time, so it's always the state, which is a form of determinism. So that's exactly what I'm talking about, a double buffer system, where we store all of the previous frame's data, and then we do our calculations only using the previous frame's data. So all of the actions that our objects undertake are one frame out of date, because they can't see the positions. So if there are two objects, and this object always wants to be linked to this object, it's always going to be one frame behind that object, because this frame moves on this frame, but I only have the last frame data. So there's going to be 1 frame of difference between those two. And there's no way to fix that. The way to fix that would be to have a source of data for that chain of objects, and then have all of them derive their positions off of that one source, and then it would lag 1 frame behind that object. But let's say you have like a chain of objects. Now, that object at the end of the chain of objects, you move the base object, and now if this is 5 objects deep, it's delayed 5 frames before that object happens. Completely deterministic, would work amazingly with rollback networking. It literally, like, the only way to solve for that would be like, I move this object once every 5 frames, do 5 updates so the updates propagate out to the 5th object, and then now we have the final state result of all the computation. But now you're running 5 update loops before you're running a frame, and that's ridiculous. Yeah. I can always find a reason that a solution won't work. And then you have the final solution, which is, or a solution that in most cases would be fine, but in some cases would be bad design, would cause errors. Isn't it industry standard to have a less computationally expensive methods of calculating the next point, an object locally, to then sync it once it's calculated? Yeah, industry standard is to do stuff as fast as possible and allow inconsistencies into your data, not compromise for the sake of speed, basically. And what I'm trying to do here is not compromise. I'm trying not to compromise on speed, and I'm trying not to compromise on determinism in the engine, while also multi-threading. I want deterministic multi-threading. Don't think in this case you cannot compromise. So I can have completely deterministic. I can have... Actually, wait, would that be... I can... have a system that runs completely deterministically if I'm fine with occasionally a system that isn't designed around that in an unaccounted for edge case. Even then, sometimes detecting that something isn't deterministic and throwing an error would in itself cause non-determinism. Because sometimes the error... Well... No... Yes? No. If you could upfront declare the data that you want to read and write, you could acquire all the locks you need in a way that wouldn't deadlock. Yes, I can acquire all the data I need in a way that won't deadlock. However, that's not the problem I'm trying to solve. I've already solved that problem. The problem I'm trying to solve is order of data mutation. I would need to declare all of the data I want in the order that I want that data in relation to other systems. Because the problem I'm trying to solve is stale data versus not stale data in a deterministic way. Could potentially, but I made my own custom async multi-read-write lock, then can acquire up to 32 read-write locks at once pretty cheaply with just a few atomics. That's the solution I'm going with for binding memory pages to pipeline segments. So I already have at the runtime of Brane script planned enforcement of the scripting language itself. We'll never run code unless it has a lock on all of the data. That's not a problem. Like, we will never have actual threading race conditions. What I'm trying to solve is designed race conditions. Since the order that scripts execute is not enforced, and I want to enforce order of script execution based on the data dependencies of execution. So you need a way to specify, I want the last frame position of an object versus the current frame of an object. Honestly, that's... I just had an interesting realization. And that realization is that if I were to, instead of enforcing scheduling on the object level, if I forced scheduling on the component level, I could deterministically, before running the code, if this component we know relies on the previous or current frame value of this component over here, and we wrote an update loop per component, basically. Write an update loop per component. So to change the value of a component on a frame, you'd have to do tick per component. And then when you do a tick request on an entire scene, you're calling tick per component. Embracing non-determinism may be okay, as long as the data is always in a valid state. No, because I want to do rollback networking, which explicitly requires deterministic data state. So, determinism is a non-negotiable for the way I want to design this, because multiplayer. I want to be able to sync the state between multiple clients. But yeah, if we can deterministically enforce that we only update a component, or not deterministically enforce. If we say you can only update a component once per frame, and you may ask for the date of a component before or after. So you have the concept of the before data of the entity, the update stage. This is the time-dependent thing. You may only have one update of data on the entity. So if you want to store multiple, if you want to set the data of a component multiple times throughout the frame, I'm sorry, you're gonna have to add more components to your object. And store, so instead of position, we would explicitly store a, like render position for the object, and then physics would rely on the last frame render position, or true object position, and then physics would then output a post physics position, and then animator would potentially need a way to specify where this is getting its transform data from. So you could say this is from this component or from this component. And to be honest, this is going to have a RAM overhead of storing more data per frame than we realistically need to. Unless if nothing ever requires a previous frame data for a component, we don't need to store it anywhere. We can just implicitly pass it to everything that requires it. But this is kind of like an explicit data-dependent scheduling. And that is something that we can check when entities are created, or when properties on the entity change. Would this cause a circular data dependency? Explicitly, we can check that. Would this cause a circular data dependency? So, ooh, okay. So instead of validating references when we want data from them, like when we request data from them, instead, because every single one of these components is going to have an explicit, I depend on the data of these components to update my value, you can create a tree of dependencies for the path that that data will take. Like, you can just explicitly model that out. It's all deterministic. And then, since this component explicitly references other components, you can check which reference in the tree causes it to break. So, let's just say there are two places where you can check to see if you're about to cause, through your references, a breaking scene reference to occur. And on initial object creation, we can check to see if there's a data race. Like, when you first create the object, you start at the component that doesn't require any references to update its value, or it requires references on scene objects to update its value. Then you can build the tree up from there to, when you instantiate an object, you can figure out, like, is this object being instantiated in a broken state, to a state where, like, it will not be able to run because of this error. You will be able to check that at object instantiation, which you can check in editor if instantiating the object will break it. Then, at runtime, since I can't statically verify stuff that will happen at runtime, you can go and, when you try and set a reference on a component, so if I tell this animator, hey, take the position from this physics entity, but we're referencing a different component, outputting a compatible input value for this for that component, then you're able to, at the time of setting that reference, you're able to walk that tree, and most of the tree will be statically cached. So you only have to check that one change, or whatever has changed, like what parts of this data flow graph has changed. And actually, no, it probably makes sense to, yeah, you just check, you construct the tree, you walk the tree when it is, you walk the tree of references when it is created. And then you can check if there's going to be a circular data dependency when you set it instead of when you call it. So, instead of me having to make people check for an error every single time they access a component, you only need to check. You only need to check for an error when you change a reference on a component. So, yeah, basically, the breakthrough is, instead of trying to figure out instead of trying to figure out how to model one update loop for an entire entity, instead we do a update event per component, and those components can specify it's not crazy. It's a great tool for figuring stuff out. But yeah, so if we do dependencies per component and then have components not have any way to grab data from other components except through explicit dependencies that are defined in their data itself, then yeah, So you would only be able to access certain components that you've upfront declared upon construction on that entity, or will they also be dynamic somehow? So, the way I'm imagining it is the component has, I'm running out of space here. The component has state, and then it also has component references. So these are like, we need data from these components to reference the data, and these are dynamic value. The components that this component requires in its update loop or update event, tick event, are dynamic. But we only validate them when we change them, so that's on initial creation and then on changing, because technically initial creation is changing them. So you update those component references, and then you have an update tick, and that update tick already has the data from those required components present. It's already resolved that, you have that data, and then you have your current state data, and then you use that to update both your component references and current state. So component references is part of state. So components are explicitly storing references to other components, yes. And I think this is a different concept than, this is kind of a different concept than entity component system components, because, yeah, your animator will have to explicitly reference the physics system, and the physics system will have to explicitly reference, we're going to call it last frame position, an explicit position component, and the component references will explicitly say, do we need the pre-update or post-update, last frame or current frame version of that data. And with that, we're able to statically verify when we change those component references, because we know the exact data flow order of events required. And additionally, if we can statically determine that a certain component is not required in the next frame, we can drop it before the next frame. Actually sounds like something similar to the creator of a popular entity component system, where he talks about a new paradigm called a component tree. He got rid of entities altogether, I believe. That is kind of the direction I'm going, where, I mean, you do kind of need an entity. You need some sort of collection of, like, here's something I can group all of these concepts together around. Otherwise you'd have a huge, like, web of components just randomly connecting to each other. So I think the way component references are going to work is, it's like, I want this entity on this component, or this component on this entity, though these component references technically don't need to reference an entity at all. Just straight up don't need to reference an entity at all, ever. Unless you're talking about sending a message to an entity, in which case that's kind of a... I still do want the ability to send messages, like, over the network and whatnot, but then again, that's still kind of... Yeah, it's just a component tree. I don't get how this would make it so that the on-time updated frame issue. So this solves the on-frame updated issue, because the on-frame updated issue is where you enforce are always using stale data. You basically say, I can't verify that any data this frame is used in a deterministic manner, so I'm not going to. I am just going to only use the data generated last frame, and then all the data generated this frame is off bounds, out of bounds. But with this design, you can create an explicit tree of components. I'm going to Google search that after this, when I'm eating food, and then do that. But basically, you go from all this data that is available at this frame, or I can figure out won't cause a data lock. I can just I can deterministically see there's no loops in here. This node doesn't reference this node. This component doesn't reference this component. And I can know that I can always do that update step all in one frame. So this also solves the off by one issue, because you're explicitly saying, I will only update this component after it has affected that component. Yeah. And technically, component references could even reference specific fields of components in the future. And I've been loosely toying with this idea. I wanted a visual representation of this where you essentially create a node graph of operations for one entity, but this is taking it one step further to where you can make a node graph that affects other entities in the scene. What if a component needs to reference a component that's referencing the other component? It can't. It's impossible for a system like that to work. Okay, so the referencing here is saying I need the data stored in the data from these entities, either last frame or current frame. You actually would be able, a component would be able to reference itself last frame. In fact, I think all of them are going to implicitly reference themselves on the last frame, because they need what data they stored on the last frame to update themselves most of the time. So that's kind of like an implicit. You can have a circular reference if it's referencing the last frame data of that component. But if you try to create a circular reference like that, we can catch that when you create it, either at object creation or when you try dynamically try to change it, and then cause you can throw an error at that time, and it's a catchable error. So I can leave that up to the programmer. You get to decide what to do with this. You can also do that with weak pointer semantics, where each one of those components is an owning component. Otherwise, you'd need a garbage collector, I'd imagine. Although I think there's an expensive way. Not necessarily weak pointer, just like reference counted. I guess you're talking about reference counting. This would be reference counted. The way that Brane script behind the scenes is going to work on a page level reference counting system. So yeah, we implicitly have a semi-garbage collector in Brane script, but it's reference counted, so never stop the world garbage collector. But I do think it makes sense, at least for programmer sanity, to have the concept of objects. But that's kind of like a design behind the scenes. I really like this component tree model. This is exactly what I was looking for. Because component tree, it's encapsulable. You can encapsulate this. And I can also make engine level components that are completely opaque, and you just rely on the data from them. And yeah. I really like this model. Okay. So this is... The person I was quoting didn't actually call it a component tree. I forget what he called it. Trying to find it out now. Oof. Okay. So I do want to... I definitely want to know what you're referencing, because that sounds like exactly what I want. Or I'm going to make something very close to it. So I think I'm going to stop streaming pretty soon and go eat food, but I want to find this concept before I stop streaming so I can research it more. Tree of components, ECS. Behavior trees? Is it called behavior trees? Not behavior tree? Oh, this is a this is for AI, like game AI. Not investor loved AI. This is for we like this AI. This is good AI. Either Hex, Gex, or Legion. So it is a Rust ECS. Is it the way that one of these ECS systems works, or is it like the creator going, after making ECS, I realized I didn't need E, I just needed CS. A component system. Talks about a new paradigm. Okay, so creator talking about a new paradigm. New ECS paradigm Rust. Let's see, this is... So hear me out. A lot of times things like this are a great situation to use AI in. We actually need one that can use like the web, so we might actually use like Gemini. Trying to find a new architecture inspired by ECS, explained by one of the there's AI taking the internet hive mind's job. Yeah. Well, I mean, it is the personification of the internet hive mind. If nothing else, that is what AI is. the AI hive. It is the hive itself that the internet hive mind lives within. One of the creators of a very popular Rust ECS framework, where you could theoretically drop the needs for entities by making trees of components. Oh, we called it component tree. Concept discussed for creators is a Bevy game engine and its ECS. The design is an evolution of the traditional. Here. And you link to where they talk about it. The creator of Bevy, Cart, has discussed the idea of moving away from explicit entities, and so is it this guy? Or... I love it when that happens. Game developer and Bevy maintainer, Carter Anderson. Okay. This dude. Yeah, Google has no idea. So potentially this, but not. And you link to where they talk specifically about component trees. Please. And you broaden the search terms. I feel like now that I'm like messing with my brain about it, I feel like I have also briefly seen like whatever YouTube video we're talking about here, and completely dismissed it at the time, thinking that's ludicrous and a ton of work. Can you broaden the search terms and search for similar concepts and source them with links? Component free ECS. We need explicitly component tree. No results. Straight up no results. Nope. So there's Flame Engine. Oh, that's a web framework. Tree wasn't in the name. Maybe it's a component graph? CGS, component graph system. Component graph system. And there's the Froggy. CGS. Was I listening to a Jonathan Blow talk? No, this is the FAT components, where it's like every object stores the data required for every single object in the game. No, though that is a good system if you're writing your own engine and like making a roguelike or something. I'm a fan of fat components when I'm making simple games. Like, that's good for a simple game. If you're making a complex game, not as much. So I'm gonna search explicitly for this because it is not outdoing... Making it performant was one of the big problems initially. Yeah. I love... The best part is, we caught this on stream of me reinventing this concept. And I'm probably gonna implement it differently than they are. But still... To be frank, component graph system didn't have anything to do with multi-threading. I don't think you invented that part. It mostly had to do with lifetime semantics and ownership and how updates work. See, here's the thing. Inherently, through how Rust works, you have to solve data race conditions in single-threaded code. So what Rust devs are going to come up with is stuff that would work with multi-threaded, because you know what the borrow checker is? It's single-threaded race condition checking. You're doing compiler-side mutex locks on your data. That's all the borrow checker is. And you're having to do mutex locking in single-threaded code implicitly. Okay, this... If you didn't know, I now have a community forum that I'm getting trolled by my friends on. But I now have a development log on a public forum. I'm very proud of this public forum. But this is where I'm going to be doing like text updates on the actual engine itself, and this is also where you're going to get to where like community help for the engine will live as well. So yeah, go join the Brane community forums if you want to use Brane Engine in the future. There's nothing really to do there except read this one development log that I'm writing at this moment right now. But yeah, it's here because I got fed up with social media and I'm like, I'm gonna create my own social media, the Brane community forums. But yeah. Okay, and I'm just gonna keep this as a draft for myself. So draft saved. I now will remember component graph system at some point, and I'll write a development log update on this at some point. Also, idea for your runtime. Threading for entities sounds similar to frame graphs for rendering where they compile dependencies every frame. Threading for entities sounds similar. Yes, I think. Where's the idea, though? Or are you saying that I should just look into frame graphs? Is a directed acrylic graph. I knew I had seen that before, because directed acrylic graph, when I was getting super into the functional programming version of BraneScript. BraneScript was a DAG. Actually, no, it was a single static assignment graph, which I guess still falls under directed acrylic graph. No, wait. I found that term when I was trying to automatically position nodes in the visual scripting system that I wrote. That was where I know directed acrylic graph from. Not flame graph, frame graph. Frame render graph. It's acyclic. Directed acyclic. Ah. Directed acyclic graph. Somehow that has deleted my remembrance of what I was saying before. Did I say acrylic? I think I said acrylic. Acyclic. Acyclic? For rendering. Not super similar, I suppose, but frame graphs are a way to detect all dependencies up front and compile those dependencies in a way to thread them optimally and create the correct barriers for rendering. Oh, so you're talking about like multi-threading GPU side. Yes, so the way that pipelines work in BraneScript is very similar to the way that threading works like GPU side, with like semaphores and all of those sorts of things. And strangely enough, Vulkan just like, I haven't reused Vulkan yet, but Vulkan, all the terms for it kind of clicked after spending this much time trying to design a completely asynchronous language. But yeah, so component graph system. I'm gonna research this. I'm gonna see if it's what I want here, but yes. I am glad to hear that this is already a concept that exists, but is like fairly unresearched, so it's like still exciting, still inventing something. But yeah. Okay, I'm gonna end the graph now. I'm gonna end the stream now. I'm gonna go eat food, and then I am going to research the hell out of this. And I think this is how Brane Engine is going to work. Is through component graph system plus pipelines, and then some amount of security on who can affect what. And well, actually, no. I don't need security, because the only thing affecting entities, or the only thing affecting components at the moment, is the input into the component's references. So, if components want to be able to change what they're referencing, that should theoretically be a value that's passed into the component, and then the component changes its references. Or I could have it be that you could change the component references of a component at any time. Actually, no, that breaks my determinism thing. So yeah, the component itself will have to be the one to change its references. Otherwise, you can't change references. Those are encapsulated as well. So, I do think I will have something like a message queue, and the message queue will always be stale data. So for systems that you want to encapsulate, there will have to be some way to send messages to components and have those components update their data if there's a set of messages. Like a message queue. And that message queue could theoretically be another component that it takes data from, and there's like a queue component. Or it could be an explicit feature that, like, these components could have public queues. That stream and stream tunnel looks like a graph. Anything can be a graph. But yeah, this graph of data is deterministic, because each frame is entirely dependent on the last frame's data. So hello, parallel processing. Alright. I'm going to do a little bit more design on this, but this is a solution that works. I'm happy with this solution. Now I just need to design how the system works and how the system gets encapsulated a little bit better, but the encapsulation does not conflict with the encapsulation doesn't conflict with performance, because I can do a SIMD update on components. Like, I can straight up do a SIMD update. Actually, wait. SIMD update on components might be hard. That might be hard to pull off. But I can do a multi-threaded update on components. And yeah. I could do batched updates of components and do SIMD that way. Those are all runtime optimizations we can worry about later. It works until proven otherwise. This is correct. The only thing I'm worried about now is optimization. But it's an optimizable system, which is what I'm happy about. We can optimize. This is I know it can be optimized later architecture. That's like, when I'm architecting something, I try to think about how could I optimize this later, and I try to make systems that can be optimized later, but I don't necessarily need to optimize them right away as long as they are optimizable later. I try not to paint myself into corners. I don't need to paint the whole room at once, but I have to make sure I'm not painting myself into a corner. Alright. This stream turned out better than I was hoping for. Component graph system. Component graph